What's up? I'm Austin Griffith. I'm here with Carlos and Etta. We are on, what is it, day 4, day 3 of week 2, day 3 of week 2. So this is like the 8th day of building. And we're gonna finish up looking at running some scripts and some GETH node stuff, setting up our own node in this big peer-to-peer network. And then we're gonna start looking at some Solidity. We might get into Hardhat and run our own local blockchain and kind of deploy a contract and test it. So the very, very beginnings of actual smart contract development will start today. But let's finish up with some GETH stuff. We built a bunch of scripts, and we had those scripts talk to Infura mostly, right? We were talking to Infura's endpoint. We were asking Infura, hey, what's the block number? And they were running their node. But in this decentralized world, we're trying to be as decentralized as possible. It's better if you run your own node. Let's see if I can get out of the way. I have my own L1 node right here. It's not a GETH node, it's a Nethermind, but it's basically L1 Ethereum, what a GETH node is. And it's talking to all like 20 other machines peer to peer. And so there's thousands of these nodes in the network, and they're all keeping track of the blockchain. They all have a local copy, and you can ask any of them anything like, what's the balance of this person? What's the block number? And you can ask them just like we're asking Infura. So it's a lot easier to kind of hit your own node and ask it questions. So hopefully, I think, Etta, do you think you could take over? Also, all of us are sick. We all have colds. Apologies to you at home for having to listen to our crusty voices, but here we go. Etta, how are you feeling? How are you ready to show some stuff off?
I'm ready to show some stuff off. Let me directly start by sharing my screen, and we can walk through like setting up here.
Awesome. Perfect. So there's a couple different types of L1. Like we keep seeing L1, layer 1. It's basically like the mainnet Ethereum chain, right? You could run GETH, but you can also run other clients. And that's like, maybe we should talk about just for a second, like client diversity. When we talk about client diversity in Ethereum, when we're running a giant decentralized network that no one is in control of, we're worried about if everyone is running the same exact client and there's a software bug in that client, the whole network could have a problem. So the phrase, client diversity is all about, let's have lots of different people running different versions of software that basically does the same thing. In case there is some kind of bug in one of the pieces of software, hopefully the network will stay up. So I have my Nethermind back here, which is one type of client, but we're going to talk about GETH today. GETH is like the major, it's Go Ethereum. It's a Go implementation of the Ethereum protocol that you can run locally. You fire it up, it talks to peer-to-peer to the whole network, it syncs the whole blockchain, and then you can ask it questions like, what's this person's balance? What's the block number? You can also send transactions to it, and it will put those transactions into the mempool too. So here we go.
Yeah, so I did install it.
Yeah.
So I actually have it installed on my PC, but maybe it would be good to like walk through a bit of the steps. It's really just to like, you have the steps over here to follow. It's pretty straightforward to follow the guide, but we'll like link the steps as well. So I basically just like did a brew install, and then that's basically all I did to install the Ethereum. And then let's kind of bring up my terminal over here. I'm gonna open a new one. Let's start from scratch. Yeah, so I basically installed the node, and now I can run it to sync it on my PC, right? That's kind of what I'm going to do. I have the command over here, so like let's directly.
And the sync modes are different too. Notice this sync mode light. This sync mode is depending on how much information you want your node to store and verify. There's the idea of like an archive node that basically stores and verifies everything and could go back to like block number 100 and tell you everything about the network at that current state, but that is super heavy. You have to have like terabytes of storage to be able to store it. Then there's like full mode, which a full node is basically like all the information and concurrently verify it. And there's probably some details here that my smooth brain is not completely covering, but it just kind of like from a high level, you've got the archive node, very, very few people run that, and it takes terabytes to hold. You've got a full node, which has the whole state of the network and verifies it locally, but it doesn't keep, it doesn't store like all the old different states that you don't need. It basically proves them and throws them away. I'm definitely not saying it right, but just this is like my high level of it. And then there's like a sync node that's like light, where it's gonna quickly sync, and it's probably, there's probably some kind of like checkpoint that it checks in on and then starts to sync afterwards, but it's much faster to sync with light node, but it's not doing like a full like storage of everything compared to a full node. So there's really just like the full node and the light node. You can get it quicker, and you can have a full node running that's talking to the network peer-to-peer. You can send transactions to it, you can read from it, or you can have a full node that's going to take a lot longer to sync and have a lot more storage. So it looks like you select a light node, which is way quicker for us. You've also opened up the HTTP on 0, so you could even talk to it from like an external machine. But yeah, it looks like we're ready to go. Let's fire it up. Boom, look at it go. Oh, it's so pretty. I love it.
So we're basically getting the content of the blockchain on my local PC here.
Yes, exactly. And you're setting up peers. See, it's looking for peers, and the current peer count is 0. So it's going to try to find a bunch of peers in a peer-to-peer network and communicate with those peers. And anytime any of those peers finds a new block, they broadcast it to everyone else, and everyone keeps the chain of blocks, and the longest chain of blocks is what we follow as the valid one. Could you stretch it out too so we could see a little bit? Yeah. Oh yeah, there it is.
Yeah,
looking good.
A lot better.
And we can see the GETH version. So it'll take a while probably to sync up and find some nodes. Sometimes with a light node, it could take like overnight to sync up, right? Have you run this before, and how long did it take? How did it go?
So I did leave it open. Like I think it wasn't like overnight. It was more, I think, like a couple of hours. But we could still like connect to it and like get the like user provider, like connect to it to see like that we're connecting to this address on my machine. So we could like try that while this is waiting. But yeah, maybe we could come back at the end of the episode and see if we have like more information here.
Yeah, let's look at that script just real quick. So we have this script that talks to an RPC, and before we were just kind of hitting Infura. We were just asking mainnet Infura with an Infura key, and we could get maybe, it took maybe like a second and a half to get an answer back, right? There's definitely some rate limiting going on there where we can't just like hammer their node. It's like an API service. It's like a Web2 service that takes time, right? So what we'd like to do is switch this to, instead of talking to Infura, we'd like to switch it and tell it to talk to our local node. And that will allow us to query the chain a lot faster. We can even have more access to things like the mempool. We could see what transactions are trying to get mined right now because we have our own local node, and we can look at that kind of stuff. There we go. And 8545 is the port that GETH node runs on.
And yeah, like it's on my local host, so just localhost and the port number. So what we could do is like try to get the block number, right? Like
let's try to get the block number from Infura, and then let's also try to get the block number from our node and see just so we're getting 2 different block numbers, and wait for those 2 to basically be equal. Cool. And so one thing to really dive in here is that there's a lot of indexers. In Web3, you end up creating what's called an indexer because it's so hard to read directly from the chain from your clients. Imagine a client pulling up their web browser and they have a wallet and they'd like to see all their transactions. This is actually a really hard thing to do. You can't just query GETH or Infura for all the transactions for a user because of the way they're stored. They're stored in blocks, and the blocks are just like these sequential blocks full of transactions. So if we wanted to get a transaction history for any given account, we basically have to crawl through every transaction in every block and look at the to and from and save it for that user. So if you wanted to provide your user with a quick transaction history, there's actually a middleware layer there of an indexer, right? And it's a middleware service that basically looks through all the blocks ahead of time and gives you a much easier, cleaner way to like query for that information. But a lot of time these indexers are centralized. And so if an attack happens or something goes wrong, you could probably like lose that service for a little bit. You don't have 100% uptime like you do when you're talking directly to Ethereum. Just to kind of clear that up. Okay, let's see what we got here. So we're going to check the block number on Infura, and then we're going to check the block number on your local node. Let's see how it goes. Hey, look at that. Both of them are caught up. Oh, my cat's yelling over here. Sorry. Great. All right. Oh yeah, and it's getting new blocks too. Here. There we go. So it only has a single peer. So your machine is talking to one other person who has connection, but it's working. We're getting blocks from them, and this is how you know that your node is synced up and good to go when it starts pulling one block at a time. You'll watch it sync up and it'll pull like 20 blocks at a time for a while, and the CPU will really spin up. But then it'll kind of get stable and get to the point where it has the full chain stored and it's just waiting for that next block to happen. And as soon as someone on the whole network, remember there's thousands of nodes, as soon as one node finds the nonce to mine the block, then all of the nodes will broadcast that information to each other and it will spread quickly, and we'll get the current block. So let's see, are we maybe even faster than Infura? I bet if we run this script kind of over and over again for a little bit, there will be times when we will be ahead of Infura. Oh, it's doing some other stuff here. Oh, it's getting Sanford's balance. Let's start getting all that stuff locally, just because we're waiting on Infura here, and let's switch it to our provider, which should be super easy. We just switch provider to local provider, right? So cool.
I think that's all.
I think that's it. Yeah. Now let's see if it goes faster. So now you should just be able to run this thing over and over again. Let's see if it ever happens where our node finds the block first. So we're 34. So we're waiting for block 35 to come in. And we could even at the there we go. Look at that. So our node, since it's talking peer-to-peer, got it before Infura got it, right? Or perhaps Infura has some error checking where they have maybe 5 or 6 nodes that are running different versions and different things, and they're seeing, like, okay, this node has it, but does anybody else have it? And make sure that like maybe 2 or 3 nodes get it before they broadcast it, or something along those lines. But sure enough, we're able to see by talking just to a peer-to-peer network, we're able to get the state of the blockchain synced up faster than Infura, the service. Very cool. Okay, so if you at home are looking for a challenge, try to set up an indexer. Build something that looks at the current block, and then you can get the block, and then you can get all the transactions in the block, and you can loop through them. And maybe we'll do that on the next episode, or we'll talk through an indexer. But just wanted to expose that you can talk to Infura, but it's very slow. If you want to get lots of blockchain data, if you want to run your own indexer, if you want to know transaction history, that kind of stuff is going to take an indexer, and you'll have to build that out. And so this is just a good way to do this. You'll need to run your own node. And also a much bigger picture thing, like Carlos alluded to, I think maybe before we hit record, is that this is a network of peer-to-peer machines, and you're participating in the network because it's decentralized. There's no central control, right? So what makes it more and more decentralized is more people running these at home. So you running a node at home means that you're just another peer for other people to connect to. Notice we still are only connected to a single peer. Some brave soul out there is letting us connect to them and get our blocks. But if that one computer falls over, then we're going to lose our connection. So hopefully you have a web of lots of different peers that you're talking to, and you're talking directly to them peer-to-peer, and you're syncing up the state. But that's participating in the network, right? We're not mining blocks, but we're at least participating in the network in terms of verifying blocks. Anything to add to that? Like just like kind of the idea of this, like running a node is such an integral part of creating a decentralized network. You need more peers.
Yeah, I was really surprised on how easy it is to like run your node, to just install the software and get it up and running. And you could really see the difference on like using a service, especially when you're like doing it locally. So yeah, like it was a nice wake up call for me as well.
All right. So I just wanted to get us exposed to running our own node, but I didn't want to do too much of a deep dive on it. I feel like it's probably time to move on to Hardhat and running. Basically, we'll run an entire implementation of Ethereum totally locally, and we'll have our own block that starts at block 0 and like a Genesis block, right? So we'll create our own local blockchain that mimics Ethereum, but we're going to kind of put away our connection to Ethereum and we're going to work locally. Hopefully what Carlos shows us next, we could basically set up on an airplane if we wanted, right? You don't necessarily need to have a connection to a bunch of peers. You can run your own kind of like fake blockchain locally and you deploy contracts to it and interact with them. But if you're ready, I think we've got things covered here in terms of just like exposing y'all to, you should go run your own GETH node. You should go run maybe a different a client, maybe like Nethermind or another client. And then there's going to be the execution layer and the consensus layer, right? And so there's going to be what used to be called ETH2, but you'll run like a Prism validator and you'll run the beacon chain. So there's a couple different types of nodes that need to be run. But we'll get into all of that later. Just wanted to expose folks to, here's the node and here's how it works. Anything I'm missing here?
I think we're all good.
All thumbs up. All thumbs up. All right. Great demo. Hopefully your peer eventually connects to some more peers. Like I feel like your node is lonely.
Well, we'll see by the end of the
there we go.
The video.
Yep. All right, Carlos, you want to take us away with some Hardhat then? Let's make a transition to, we talked to Infura, then we spun up our own node and we talked to our own node. Now we're going to spin up our whole own blockchain, right? We'll create our own blockchain locally and we'll talk to that next. And that way it'll be free and easy and cheap and we'll be able to start orchestrating some smart contracts.
Yep. So first, like, sorry for my voice. It's a little, yeah. So I'm sorry. So can I steal the screen from you, Eda?
Go for it. Yeah.
Oops, I can't. I think you have to.
Oh no, you might have to stop and
Stop.
I
okay.
might. There we go.
Yeah.
There we go.
Okay.
There we go. We got Hardhat.
Okay, Hardhat. Yes. Okay. So I think you already did like a good introduction of what Hardhat is, right, Austin? Not sure if you want to add like anything else.
I would say like along with it's going to run a whole blockchain for us. It's also orchestration software, right? This software is set up to compile contracts and deploy contracts and even test those deployments. So Hardhat isn't just our local node. It is a local blockchain, but it's also all the software involved with taking Solidity and compiling it to bytecode and then deploying that bytecode to the chain and then testing whether or not that smart contract does what it needs to do and all of that stuff in between. So it's not just a chain, it's actually orchestration and testing software. And it's also included in Scaffold ETH. And we're getting you exposure to it at a low level, but pretty soon you'll be using this stuff and it'll all be kind of under the abstractions and you'll just be firing a command and everything will work. But we want to show you the guts first before we really show you Scaffold ETH and the speed run and everything.
Yeah, that's a good point. Like Hardhat is not only a development environment, like a local environment, it also allows you to deploy contracts to mainnet, right? So you will use Hardhat for local testing, for compiling contracts, but also for deploying to mainnet. So I think maybe the first thing that we can do is installing Hardhat, right, on our local machine.
Sounds great.
There are like two ways of going, of installing Hardhat. The first would be just to like install Hardhat standalone and then going from there. But I really like this MPX Hardhat.
Yeah.
So because it allows you to select like a sample project, which I really like because it gives you like you get like the full picture with all the folders and the files that it creates, you get like the full picture of what Hardhat can do. So we use like nodes and npm and npx. If you don't know, that's actually like a command that allows you to install or to run binaries that you don't have in your machine. So the first time that we run npx Hardhat, it will actually look to the npm repo and will run that binary for you. But then if you install Hardhat locally, this npx will run your local instance in node modules. So so here, I think this is from yesterday. Yeah, so let's create a new folder here. Let's call it day 3 to be original. And okay, so now let's cd into day 3. This is an empty folder. So let's install Hardhat here. Can you see the screen? Can you see like the text is all good?
Yep.
Yeah.
Yep.
Okay.
Yeah. We see the Hardhat ASCII. Yep.
Nice. Okay. So there are like a few options here. I usually go with the basic sample project. So we are going to do that. This is the project root. Yeah, let's do that. And yes, Hardhat comes with some dependencies that let's also install them. Like Waffle is just like for testing stuff. Chai, if you're familiar with Node.js testing, you probably are familiar with Mocha and Chai. And also you have this plugin called Hardhat Ethers. And what it does is take ethers. Like we know ethers, right? We have been using ethers in the last few days. So Hardhat Ethers, what it does is just provide like another utility functions inside ethers. So you can do a few things quicker and more. Let's see here. Hardhat Ethers, I think. Yes. So this plugin, and you have like a few utility methods here, like the signers, get contract factory, and also it gives you like the a provider shortcut, I think. Yes.
And all the utils like parse ether and format ether
yeah.
are still in ethers, but they just extend that and add some
Yes.
more things that you're going to need.
Extend, that's the word. Yeah, it's extending ethers. Thank you. Yeah. Okay, so this is still installing dependencies.
And maybe we should talk about, there's also other options other than Hardhat. Truffle is another orchestration that is kind of the OG. You used to Truffle compile. I built my own orchestration software just using Sol-C. You can go to NPM and find Sol-C, and it's basically a compiler. You can give it Solidity code and it will spit out bytecode. And then you can deploy that bytecode to the network by just making a transaction. So you can build your own orchestration. It won't be fun. And there's lots of great things to do this now. And there's a new one called Foundry that's written in Rust that also does the same thing. It'll compile and test your contracts and deploy them to another network. And so there's options here, but Hardhat is kind of the current de facto. This is the way to go. It has really nice things like you can put console logs in your smart contracts, and it will spit them out to you here. And it's also built into Scaffold ETH, which is like kind of like week 3, we will be doing a lot of like full-on dApp building, and a lot of it will be backed by Hardhat. So we're showing Hardhat now, but know that there are other options, of course.
Yeah. Okay, so the installation just finished. So let's take a quick look of what it did when we ran this example project. So it created, I mean, we are going to dive deeper after, but let's take a quick look first. So it created like this greeter contract, also created this sample script that we can run from. We can do like run Hardhat, run scripts, sample script, and we can also do node scripts and then the name of the script, and we will see that there is like a difference. Also created this sample test. This is actually like a unit test for the contract, And also this file, which is very important, is the Hardhat config file that right now is like kind of empty, but we will be filling it later. So I think the thing that I most like about Hardhat is being able to run the Hardhat network and the Hardhat node, right? We just talked about the Ethereum blockchain, the Ethereum network, and Infura, which is like a node or our own node that connects to that network. So we can do the same thing with Hardhat, but locally. So if you do npx Hardhat, I think it's node, right?
I think so, yeah. It's actually going to build a blockchain for us and fire it up. Yep. So
you see here, like this is setting up a local blockchain, and it's also setting up this JSON RPC node for us, so we can connect to this, the same thing that we connected to Infura, or the same way that we connected to EDA's node. This is the same thing, but locally.
And if we had that script and we said, what is the current block number? It's going to say 0 or 1, right? We're going to be on the very first block right now. Yep, the Genesis block.
The Genesis. So also something really important is these accounts that Hardhat created for us. So this past day, we have been creating a lot of random wallets, right? And random mnemonics and random private keys. So be careful here, because I mean, I think it's here, but Hardhat, like these addresses are 100% deterministic. So everyone who is running Hardhat in their local machines are going to get the same exact private keys and accounts. So don't use like these addresses as that, like the same thing that we did like yesterday, for example, that we will create like a new mnemonic or new private key, and we use that for sending funds or whatever on mainnet. So this, like everyone is getting the same account.
And I bet there is mainnet transactions, right? I bet if you copy and paste that address into Etherscan, we'll find that some people inadvertently, unfortunately, have made some transactions with that account. And this is something, so we were talking about Truffle earlier. Truffle did it a little differently. They give you a random account every time. Yeah, look at all those. So anytime anyone accidentally YOLOs some money into that account on mainnet, there's probably bots that are just set up to drain that as fast as possible, right? Because that private key is exposed. It's kind of strange that Hardhat uses the same account every time for everyone, instead of giving everyone a fresh mnemonic each time they run it. But I think that's so you have like a good deterministic test suite and you know all these different accounts every time. But yes, to reiterate, be very, very careful with these accounts and know that you do not want to be deploying to mainnet with the Hardhat accounts that are generated for you with these private keys that are exposed to everyone. But they work great for local stuff because it has what, 10,000 Ether in it. So we have more money than we need. We're good to go, and we can like deploy and send money around all we want using these local accounts on our local chain.
Like we can actually add this private key to MetaMask, right? So we can just grab this private key and going to MetaMask.
But remember, it needs to be a dev MetaMask. If this is like your main MetaMask and you have real funds in it, and you're also adding these random private keys that are exposed, you're setting yourself up for some real terrible outcomes. So make sure this is like a development Hardhat or a development MetaMask, and you're just adding this because you want to do some, interesting orchestration things with that account. And you're connected to mainnet right now, so you'll want to connect that back to your Hardhat.
I just created a new one. Yeah, so I have to import, right? I think I clicked into create.
Okay.
Yeah. So let's paste it here. Yeah, like F39, right? That's the same the one.
And if you go to localhost, you'll have a huge balance if you connect to the right network.
Yes. So we are in mainnet. Let's go to localhost.
Localhost. Big money.
Look at that. Look at that.
What I could do with 10,000 Ether.
Like, can I transfer this to mainnet somehow?
Yeah, exactly. Let's bridge this. Yeah.
Okay. So, I think let's try to use some of the script that we used for day 2. And use some of them to do the same thing, but in the local Hardhat network.
Yeah, that's a good idea.
I think. Oh, let's for example like get the balance of this address, right? So I'm going to copy this one. Well, let's first create a new script called get balance. Okay. Oh, and another thing, remember that we use this type module in the other things to use like the ES6. I don't know if you remember, but on the last few days we have been using ES6, and here by default Hardhat is using the common yes. So I'm not going to change anything. So let's keep with common yes, and also it's like a good way to see like the other way to do it, right? Not only
so in
ES6.
this case, in the package JSON, you don't have that whole type equals module thing.
Yes.
There was a type module, and it's not here in this case, and so we're using the require instead of the import.
Yeah, like all the scripts and all the tests are using like this common yes. So I don't want to change it right now. So let's use this common yes. Yes. Okay. So I just copy the sample script, and then I'm going to delete all of this. And okay, from this script that we have here. Okay. So now instead of using the Infura URL, let's say like the local provider, right? URL. And you can copy it from here. Oops. No, okay. So with this, the provider now points to the local network, to the Hardhat network. So we can do something like that we did before, previously. Like let's guess the balance from, not from Vitalik, because Vitalik won't have like any money. Remember that we are using like a local blockchain, right? So there's like no data, like we are like on block 0, right? So only these addresses will have money on it. So let's do something like account 0 address, and this is going to be this one. Okay, and now account 0 balance. This will be provider. Get balance account 0 address. Remember that we need an await here, and then if we want to pretty print this, I think we already know this, right? We need the ethers utils, I think format, right? Format headers.
Yep. And you said account 0 because there's a whole array of accounts. Oh, it even says account 0. We call it the 0 account all the time, and I don't know if people. There's also the 0 account is in all zeros, and that's where people burn things. They send money to all zeros. But I call it the 0 account myself all the time. It's just the first account in the Hardhat list of accounts that it gives you, that it pre-populates.
So let's open a new tab, because we want to like if we close, I mean, this tab is going to close the node. So we want the node to keep running. So let's run this script. So it will be, well, 83.
And that node will report back to us whenever we ask for things like block number. It'll let us know each RPC call that comes in, so you can see kind of like the action that's happening on it.
Yep.
Come on, big number. There we go. So 10,000 ETH. So much.
And yeah.
And there we go. We see that it did a chain ID and a get balance. Yep. Exactly.
Okay. What if we try to send ETH from one account to another account?
Okay. Yeah. Maybe try to send Vitalik some of our testnet ETH just to prove that we can do it.
Only like a 10%.
Yeah. You do. Yeah.
Okay, send ETH script.
And you almost need these, like just tinkering around. You almost need to build a few scripts. You'll find as you get better at being a Web3 developer, you have just like a these little Swiss Army knife scripts of yours that you have and you run against nodes all the time, checking balances, sending value, things like that.
Yep. So let's check the send if script that we wrote yesterday. And
looks like
actually,
it's got a Rinkeby provider.
Yes, but we can save a lot of this stuff because of Hardhat. Because here we have to instantiate the provider and the signer like all the time, but Hardhat can do that for you, and you can save like most of this stuff. But let's copy this and let's make this work, and then we can use some Hardhat utils for it.
Got it. So we're taking scripts from day 2 that are in a different folder, and we're bringing them into day 3 where we have Hardhat installed, and we have that other implementation of Ethers that Hardhat is wrapped. So we are still writing Ether scripts, but we're going to leverage some of the extra stuff that comes along with Hardhat.
Yeah, like for example, remember that we implemented like these get providers and get signers. This was some utils function that we created, and I mean we can go there. And it just instantiates a new wallet and with the private key, the provider, and all of that. But with Hardhat, what you can do, there is you can do 2 things here. You can have Ethers from Ethers and Hardhat from and this HRE from Hardhat, or you can also import Ethers if you want from Hardhat. But let's do this. And now, for example, we can do Hardhat signer, and this will be. So what we are doing here is we're accessing the extended version of Ethers that Hardhat has. So we can do, I think it gets signers, right?
I'm not sure. We'll find out. Let's console log it.
yeah, let's do that. Yeah, let's return here. So will be signers. So let's console log signers. Get oh yeah, it's importing some stuff here that we'll need. Classic. Yeah.
It's a promise.
Okay, so this looks like an array of signers, right? Yes, like as you can see here, when we created, like when we started the Hardhat node, it gave us like a list of accounts, right? Usually, you know that from the same mnemonic, like you can derive, as we saw just the other days, you can derive like multiple accounts. So what we can do is maybe getting all the signers and then getting the first one, right? Like the F39, I think that's the one. So.
And then maybe we just output the dot address of that or something.
Yeah.
And it should just be the F9 or something.
Yeah.
F9 address, please.
Here you go.
Yes.
So you see that with Hardhat, we save when on the other script, we have to do like this util to getting the provider, getting the signer, you know, and then inside here you have to instantiate the wallet with the private key. So we save all of that with Hardhat because already does that for us. So here we have the signer already. So we can do this. My balance will be like Hardhat signer with balance. This will be the same. Well, let's send to address. Maybe we can use like some of the account number 1, for example, to send like some. Oh, no, here. Account this like 70, right? Yeah. So sending ETH to address, and then the Hardhat signer to address, and then we are sending 10%, same thing that we did the other day.
Cool.
Okay.
So we have multiple accounts set up on our Hardhat, and we're going to use account 0 to send 10% of the value to account 1, and we can just kind of double check everyone's balance after that. Neat.
Yep. And we will also see, because right now we haven't made like any transaction yet. You only have like this reading stuff, but we are going to see how a transaction is happening here. And yeah, let's clear this scripts. Then this is send it. Okay, so it seems
transaction mined.
Yeah, this is the hash, is 6F. And if we go to the node, you see that nothing happens. Any ideas?
I don't know. What's going on?
I think.
What did we do?
Remember that I said that you can like run the nodes this way, like the scripts doing Hardhat run and then the script.
Uh-huh. Oh,
So
so you're running it outside and it's not. Wait, what? So what node is it talking to? So confused.
Yeah, that's true. I mean, it's well. Let's first see if this works.
Okay.
And then.
So where did it send that transaction? I don't understand.
Yeah, me neither, actually.
Okay.
But this works.
There we go. There we go.
Yeah, I mean, actually, like I have like an aha moment with this because Hardhat provides like 2 localhost nodes or networks. One is localhost and the other one is Hardhat, which is the default. And when you use Hardhat, it's only for testing. It's like a spin up like a network.
Like super ephemeral. Yeah.
Yes.
Yeah.
And then it closes whenever the script finishes. But if you want to like send the transaction to the local network, like the one that we have here, you have to specify network localhost.
If you're using MPX or something like that, is that right? It seems like overcomplicated, but maybe that's just because they want. Yeah.
You can also do this, I think.
There we go. Yeah. And just set it as localhost, and then we can just say, yeah.
Yeah. So I think this will work.
So we're sending 10% for a second time.
Yep. So it works.
Yep.
It works. So now I'm curious if this is going to work. Like that, you know, like only with node directly. Yep, it worked.
Okay. So that default network was pretty important. Is that right? Like it was, there's this ephemeral network that spins up for you to like hit. It's almost like an in-memory network. And then there's like your local host network, and you just need to tell the Hardhat config, let's talk to local host network. We don't want to spin up anything ephemeral or hit the ephemeral one. Because we are using like this Hardhat wrapper, right, from Ethers. So that, I guess, is reading from this Hardhat config file or the command line. So it was using the Hardhat network, not the local host network. So that's like ephemeral, I think is the word. Yeah. It's the same thing that when you run a test, like it spin up this ephemeral network just for the test. And when the test finishes, the network is gone. So we want to, I mean, yeah, we can do this default network, and then we don't have to worry anymore. Awesome. Okay. So we've got our network up, we're connected to it. We've got accounts, and those accounts are able to send things around. It's probably time for some Solidity here, right? It's probably time to start looking at a smart contract and looking at orchestrating the deployment, the compiling, all of that stuff. Even the artifacts that maybe come out of this, right? Like when you do a yarn compile and it creates the bytecode, there's probably a lot to learn here. Yeah, I think it actually already did it. When I run like npx Hardhat run, by default, I think it just like compile so it's already here. But yeah, so let's. Here it is, Solidity. Yes, Solidity. We're 8 days in and we give you Solidity now. Yeah, I think like we saw like some Solidity on the Sanford Stout NFT or something like that. Yeah. But yeah, I think that this is the first time like having a Solidity contract in our IDE, like looking at it, and we are going to deploy it, and we are going to make some changes, and we are going to test it. So yeah, I mean, if you are familiar with any like OOP programming language, like this is probably looks familiar to you, right? This is like a class with some properties, is how they call this, right? Properties usually, right?
And then some function, a constructor function, which is also really typical on the classes, and then some function. Actually, this is like a read function, and this is like a setter, a getter and a setter, right? This is like super typical on OOP. And I mean, this would be pretty easy to understand, I think. Is the constructor just runs whenever you deploy the contract, and only that time. So all this code is run once when you deploy the contract. And then you have this function. And usually these properties that you have in a class, if you come from a Web2 background, usually this always stored in memory, right? And in some cases you might store this on a database. Yeah, you might persist this on a database. But here, when you deploy this on a blockchain, on a network, this is going to be always stored on the blockchain. So if you make a change to this variable, for example, here, right, on this set greeting, we are changing this variable. This is not in memory. Like this is actually, when you send the transaction, is actually changing the status of this, of the state of this variable.
To dive into that just a little bit more, like you're building a smart contract and you're deploying it to Ethereum. And what that means is all those people that are running those nodes, they all have a copy of your smart contract. And this greeting, this storage element is stored on all the nodes. And everyone has the smart contract and everyone has the storage for that smart contract. So you can ask any node on the network, what is the value of the greeting? And it can tell you. And then if you want to change that, right? So that's a reading. If you want to write, it's just a transaction, just like everything else. You have to craft up a transaction and call the set greeting function. And we saw call data and we saw kind of the anatomy of a transaction earlier, but the to address would be this smart contract. We would set greeting and then we pass a greeting in. And then that storage element for that contract would get updated on everyone's machine. And then if you ask the new value, it would be the new value. So there's a lot going on here, but this Solidity should give you a real kind of like bare bones view of like what a smart contract is. And it doesn't live on one machine. It's a program that runs on all the machines and you get the exact same answer everywhere. But this is great. Good introduction into Solidity and smart contracts. I'm excited to play with it more.
Yeah, and one thing also, no, sorry, go for it.
Sorry. I was just gonna add, so we did interact with smart contracts yesterday, right? When we were talking to the DAI contract, we got the ABI. Just as a reminder, like we saw like getting these values and like functions, but not like how they were written. But when we had like the APIs, like we talked with the DAI contract and Stanford NFT contract, I think.
Yeah.
And when we compile our greeter, an ABI and an address will get created, right? Well, an ABI gets created when you compile it, and an address gets created when you deploy it.
Yep.
And hopefully we can do all that locally and test it locally to make sure it's all going to look good before we send it to mainnet Ethereum.
So actually, this sample script that came with Hardhat is actually, I mean, let's rename it because actually it's a deploy script.
Nice.
Yeah. So this is also using Hardhat, like the extended version of Ethers, which has like this get contract factory, and just by the name, it gets the contract, just doesn't need anything else. And with that, this is sending the transaction to the mempool, right? And this is waiting until the contract is deployed. So I think like we can just like run it, right? Let's
go.
Yeah.
And this will be on our local node, right? It'll be deploying it to our local node just because we got that network selected.
Yes, like if not, because we have like this default network. If you don't have this and you run this command with any flag, it will happen the same thing. It will get deployed to the Hardhat network, and so you won't see it here because that's like ephemeral. But now it should be okay. Yeah. So let's do Hardhat run scripts deploy. Let's see what happens. Nice. So we have an address, and if we check our local node,
there's even a console log. There's the contract deployment.
Yeah, the contract address from, this is like the F39, remember, like the first, like the 0 account from Hardhat. And then this console log is nice. I think it wasn't included in the first version of Hardhat, right? It took some time to them to include that utility, which is super nice. So you are able to do, sometimes something is failing and you want to log here what this is or whatever, and you can print this and see this here, which is like super helpful.
It sounds crazy that like console log is like how we're doing debugging, but it's so nice. Before this, basically what you had to do is have like events getting triggered and you had to go read those events and listen to those. So with the console log, they've abstracted it away and they've kind of hidden it, but it allows us to get information back, and you can throw stuff in that console log and get some feedback from your chain about what the heck is this value? Why isn't this math working out the way I thought it would? There's a lot of debugging that can be done with console log.
Yep. So any volunteers to give like an overview on this artifacts folder?
Yeah, we should look at it. Let's recompile the contract. Let's add some, maybe like add a little counter to it or something like that. Just add a new uint 256 count or something like that. Just add a new value to our contract. Just make a small change to it and make it public so we can see it. Yep. And call it counter and just set it equal to 10 or something like that, right? So yeah. We changed our contract up. Now, can we compile it to make sure it works? Do we have a...
Oh, I think if we
let's just deploy the whole thing. Let's ship it.
Yes.
It'll compile and go. Yep.
It just detects the change that we made, and then it compiling it again. Yeah. So you see here, compile one Solidity file successfully. Yep.
Awesome. So we redeployed a new contract, and each time you compile your contract, these artifacts get created. Is that what we wanted to dig into here? Is we can go to artifacts and then contracts, and we can see the greeter in there and see the ABI and the bytecode and everything.
Yeah, and also one thing that I wanted to mention, that once you deploy a contract, like you can't make any change to it. And that was at the beginning, I was like, oh, so this is wrong. How can I change it? So you can't, basically, you can't. You have to deploy a new contract with a new address. So that seems like basic, but for me, it looks like, okay, so I can't change anything. So I need to deploy a new contract. So
this is a great insight in terms of smart contracts and building decentralized apps. If you build a good smart contract, it usually means that no one can stop it, not even you. And so you're kind of like building these unstoppable, always on apps, but they're super expensive to run because they have to settle on chain. And so there's only certain circumstances when you want an always on unstoppable app. And that's what we'll get into in the third week. But just know that that's what we're doing here as we deploy these smart contracts.
Okay,
there it is.
So I think this is
there's the ABI.
Yeah, yes.
Which tells us, here's the different functions and the different storage elements. Yep. If you go back to greeter.json, there's more there along with the ABI. There should be the bytecode if we keep scrolling down.
Here, yes.
Yeah, there we go. So that's what it compiles into. That right there is what goes on chain.
Yep.
And if you think of it like embedded controllers or assembly, I mean, it's kind of like assembly, right? It compiles your Solidity down to machine code, and that machine code is encoded into this bytecode here. It's basically like jumps and stores and assembly language stuff that's like way low level.
Yes. So anything else that we want to look into these folders?
I think that's it. Just showing that the bytecode is there and showing that the ABI is there and showing these artifacts are created whenever you do this compile and deploy with Hardhat. I think that like now that we've deployed our contract, we probably want to test it, or we want to at least like poke it and ask it what the counter value is and do some of that stuff.
Yeah, so let's interact a bit with our contract with a script, and then maybe we can do a test later. So
sorry, I just wanted to add a reminder that because also this is on your local host, like you can't search for that contract address on Etherscan or like another tool. It's on your own PC at the moment. I sometimes like accidentally go through all these phrases and it's not there. So just like a mini reminder.
Yeah, that's a good point.
An extra tricky thing there is that contract addresses are deterministic based on the deployer address, and the deployer address is deterministic based on the mnemonic, and everyone using Hardhat is using the same mnemonic. So just like we were able to go to Etherscan and find that some poor people are using that address there that they shouldn't be using, you'll probably also find that some people sent some money to some of these contract addresses that they shouldn't have. But you'll get, if you tear down all of Hardhat and you bring it up again and you deploy the first contract's always going to have the same address. So let's see. Yeah, there
are
we
like
go.
some ETH here.
There's even some ETH. There's $83 in that contract.
Yes. Yeah, so you're right. So this is the first time that we deployed the contract was this one, right? So the contract address was CF. So if I stop this, like the node, and run it again, and deploy it again, I should get like the same contract address.
And
right?
also, our balances all just got reset there because we used number 0 to send 10% to number 1 a couple times and their balances changed. But when you took down the node and you brought it back up, it resets all of that stuff.
Yeah, cool. So let's create like contracts, contracts, yes. And let's do like some interaction with our contract. So yeah, let's use let's contract address, and then take this one. So just a recap what we did. So contract read, right? So this is what we did yesterday to interact with a contract. We have like this Sanford NFT contract. In this address, it was deployed on Rinkeby, and this is what we had to do to instantiate a contract in Ethers, right? We have to create like a new contract with the address, the ABI, which is like this file that we created with all the information, and then the provider. But now, since we are using Hardhat, it's easier than that. The same thing that we just saw on the send ETH, right? Like we can get the signer this way. So the same thing goes with contracts. So you can do, let's call it like Gritter, right? So the name of the, and then let's await. Same thing. We are using the Hardhat ethers, and it has like this get contract add function.
Cool.
So here you can just say the name, which is Gritter, and then the address. So this, what it's going to do is like create this Gritter contract instance with the signer already on it. If we don't say anything, it's going to use like the first account or the zero account is going to use. So if you want to send if you want to do like a write in this contract, if you want to call this set greeting, it's going to use the first signer, the zero address. So first, let's do like a read. Let's see, and then let's see what is here. Like the initial greeting. This is going to be greeter. No, sorry, greeter dot. It was greet. What do you think?
All right, let's see if it works. I don't know. I'm about 50-50 on it. Where are you at?
50-50? Oh, man.
I think higher, like 75.
Yeah?
Thank you. Thank you.
A lot of confidence. So it's going to basically go talk to the contract that's already been created, and we get a greeting, initial greeting. Is that what we deployed in the constructor?
I think in the deploy script, that is what you.
Awesome.
Yes, hello Hardhat. It's like the
hello
initial.
Hardhat.
Yes.
Awesome.
Okay. So now let's change the greeting. Let's do like a set greeting transaction, and it will be greeter. It is set greeting, and it takes this greeting string as a param. So let's do I don't know. It is working. And then remember that this will just wait until the transaction is sent to the mempool. But let's wait until the transaction is mined. And by the way, I just read that Hardhat has this, by default, it has this auto mined setting. So that means that the network is like stale, but whenever detects that you are sending a transaction, it just creates a new block. So it's just waiting for you to send a transaction. But if you want to mimic like Rinkeby or mainnet or something, you can also configure Hardhat to be mining blocks like every 15 seconds, for example. But in this case, it's just waiting. So whenever we do this, it's just going to mine our transaction. Okay.
That's a good distinction to make. We kind of didn't talk about that before. On any public network or on mainnet Ethereum, there's just like a periodic blocks are getting mined as fast as proof of work can find them, right? But locally, we don't have proof of work happening. We're kind of just like, but it's probably some kind of just like heavy-handed proof of stake validating the transactions. And so they just happen whenever they come through. Or you can set them to be periodic, which makes it really weird, like when you're checking for like timestamps and stuff, because if you ask the block, if you ask the chain what the timestamp is, it's not going to update until you make a transaction and force a new block.
Okay, so you see what I'm doing? I'm just like setting, I'm reading the initial state of greeting. I'm just printing that out. I'm sending the transaction with a new message. And now, after the transaction is mined, I'm just reading it again and see if the value actually changed.
And hopefully it says, is this working? Let's find out. Let's find out if it's working.
Any percentage for this?
Oh man, I'm way higher now. Now that like we've got things working and we're kind of like iterating through it, I'm like 90%.
Okay.
Yeah.
90. Okay, let's go.
Yeah.
Okay.
It is working.
Working.
Yes. Awesome. So we've spun up our own local node and we've deployed our own contract to it. And now we're writing scripts that let us talk to that contract through Hardhat, basically reading from that contract some values and then putting in the transactions to write to those contracts. So we're kind of interfacing with our contract. And this is like this is the kind of like development mode you get into. Okay, I need to build this smart contract. I create it in Hardhat. I write it out, and then I kind of like write scripts to talk to it. And then eventually you probably write some kind of like a test bank or some kind of test suite that tests against your contracts. Is that next, or what?
Yeah.
How are we doing? What's next from here?
Yeah, I was thinking on testing. I think it's like the last part that we need from Hardhat.
Cool.
So maybe we can like run the test and then make a change on the contract and break the test and then fix the test, or I don't know, something
cool,
something like that.
And what about deploying our contract to like Rinkeby or something like that? Is that something we would do through Hardhat?
Yeah,
cool.
Because I mean, like I said before, like we are doing everything here seems like super local, like development mode, but Hardhat actually lets you deploy to mainnet if you want. And yeah, like we can, maybe we can explore that. Yeah, maybe we can like set up like this, there is like a networks property here. So we can set like maybe the Rinkeby network with some provider and some mnemonic or private key and deploy a contract to Rinkeby. Maybe we can do that, but maybe
let's try testing first. Let's see how far we get with testing. Yeah, I feel like testing is a pretty critical thing and one thing that Hardhat excels at.
Okay, so this is for running tests with Hardhat. You can just do npx Hardhat, I think test. That should work. That's what it's going to do, is just looking at the test folder and running all the tests that are here. And we have like this sample test that was created for us when we created this sample project. And we can read the test right now. So you can see that what it is doing is deploying the contract as we did on the script. Then after the deploy happens, is testing that the greeting is equal to hello world, which is like the same string that we pass on the deploy. And then it's actually doing like the same thing that we did here, right? On the contract script, like we just, you know, read the initial greeting, set a new greeting, and then read the new greeting. But the thing here that we were testing this like manually, right? Because we were like just checking on the console and say, okay, oh, look, it is working. But it is way better if we use like automated testing, because you don't have to, you know, you don't have to just like trust your eyes. You will see here like, okay, this is working.
And this kind of shows why they have that ephemeral network also, because if you have like a nice network that's going to stay up all the time locally, and you're constantly deploying contracts to it and testing them, like when your test includes deploying the whole set of contracts and then testing them, it makes sense to probably just have an ephemeral chain that comes up for that. You deploy everything, you test everything, and then you tear it down. What we were doing is we have a nice like local one that stays up, and then we deployed it, and then we kind of like copy pasted the address to it, and then wrote some scripts that go and talk to that address.
So actually,
yep, go ahead.
I'm sorry.
Go ahead. No, that was it.
I was going to say that
go.
I think that because we changed this localhost, I think the tests actually are using the localhost.
Yep,
so
exactly.
If we remove this, because I ran the test and I was getting the calls here. So if we don't want to mess with this local network,
we can probably just close that node, right? For now, we can just shut that node down and just run our tests against an ephemeral network that it'll spin up for us as we need it.
Yes, but what I wanted to show is that if we have like the default network here and we run the test, it is actually like doing things in our node. But if we change this, it's going to use the Hardhat network. So as you see here, like nothing is happening here. Make sense?
Yep, makes sense to me. There's the Hardhat node that we spun up, and it's our own local blockchain, and we can talk to it, and we have all these accounts. But then there's this other ephemeral chain that it spins up just to run a set of tests, and then it tears it down when it's done. Is that probably a good way to say it?
Yes, because maybe I don't know. Maybe let's see what happens if we do this. Maybe this will use the, I don't know. Maybe this will use this. Yeah,
it should, right? Yeah, it's going to use it. Yeah. Yep.
Yeah. Okay. So I think it's just like important to make that distinction between the local host and the Hardhat networks. Okay. So what if let's break this test, right? Like this is why tests are useful, right? Because if this is a very simple test, a very simple contract, but imagine that we want to expand or change this contract, right? So if we don't have like unit testing or this testing, like we will have to check like manually that everything is still working after the change. But what if, for example, okay, what can we do? Let's
just set the greeting to something static. So,
well,
oh, okay, you got it.
I have something better. Yeah. So let's say we have like this logged bool value here. Is by default is true. So whenever someone tries to set the greeting, it's going to require like to be unlocked.
Cool.
So
then the test should fail because it's locked.
So what is happening? Can you like explain what this require does?
Yeah.
When you spot a require on your contract, what is that really doing?
I feel like require is one of like the most important things in a smart contract. In Solidity, we have this thing called require that it kind of sounds like you're importing a package, right? When you require in JavaScript, you bring something in. But in this case, this is more like an assert. It's making sure that a specific logical condition is set. And if it's not exactly how we want it to be, it will revert. So we're requiring that basically locked is false here, right? We're requiring not locked. And if that condition is false, then, I mean, if it's not set right, it will revert and the transaction will fail. But if locked is set to false, then it will continue on and it will work through the thing. So it's basically like an assert.
It will be easier if I do this, right? Because maybe this was confusing. If I do like the other way around, if I say unlock, I think this reads better, right?
Yeah, I think so. I think it does read a little bit better. Calling
Yes,
it
because now
unlocked and
it
then-
requires this to be unlocked, right?
Yep.
And so if not unlocked, we are going to revert the transaction with this message. Okay, so now let's see, okay, so we change this. And so let's say before we deploy it, let's test it, right? That's why we have test. So we run our test and compiling and breaking. Yes, so yeah, so you see, withers who return the new greeting once it's changed, and it's saying reverted with reason string. Sorry, this is locked, right? So we spotted like this bug just because we have the test, right? So what we need to do now is just to fix the test, right? So we first will go to the test and well, let's copy this thing. And so we'll probably want to have the use case for that change that we made. So should revert if the contract is unlocked, is locked, right? Or maybe it's not unlocked. Okay, so we can do this. So reader contract, this is getting deployed, and then let's change this, and then well, let's try to send this transaction, which should revert, right? And with this Hardhat waffle, you have this. I think it is. You can grab this. You can say expect this. I think it's.
And it's like Mocha, isn't it? If you wanted to know where you're finding this expect and this to be reverted, is that waffle or Mocha, or where would we look that up if we wanted to go find the docs?
I think yeah, it's a bit messy because I think it's a mix of waffle, Mocha, and chai. It's like the three libraries that we are using.
So chai,
so I'm not
is
sure.
the other one. I forgot to say chai. Chai.
Yeah, I think chai
yeah.
is the one that provides like the expect. And actually, I think this is. Here.
Yeah, I think if you Google waffle and then chai matchers or chai with waffle, you're going to get all of this. Expect to be within, expect to be close to, expect to be greater than, that kind of stuff.
So I think this test should pass, right? Like we are just checking that the unlock is working, because we are saying, okay, if we try to set the greeting, we expect it to be reverted, right? So that should be working. I mean, we still have like to make this test work, but let's check.
Sounds good. Let's see. Yeah. I remember when I was writing my own orchestration software, it was particularly hard to like catch the fact that it was reverting because it wanted to really throw. Like we want it to revert and we want to check that it reverts and we want to keep running. So that was a trick, but it worked perfectly here.
Yeah, like that also happened to me. And sometimes it's because you do this, like you have the await here, like inside.
Yeah, so the promise doesn't get to the expect and it doesn't know to try catch it. And it actually throws in there. Yeah.
Okay. So now this is working, but I guess that we need a way to flip or to toggle.
To unlock it. Yeah, we need an unlock function in our contract. Yeah.
Yeah. So let's do a new function called like.
We're writing Solidity, Anon.
Oh,
welcome. Here we go. The third week, we're going to write so much Solidity. It's going to be awesome. You'll get all the Solidity you can handle. But at first, here we go.
I think something like this should work, right?
Yeah, it looks like it toggles it. And anyone can call it, like very, very, there's no defenses here. Anyone can lock it and unlock it. Here we go.
Yeah, we'll probably take a look at this ownable interface that we can use here for, with some function with, I think they are called like modifiers, something like that. So you can do something like this, and then this will get called like before the function. And if you are the owner, you won't be able to run this function and it will revert, right?
Yep. We will inherit an ownable pattern from someone else, and then it will have a variable that tracks the owner, and then it will make sure using a modifier that the owner is someone else. But we'll get into that later. Let's just make sure this thing does what we need it to do.
Yeah. But for now, like, welcome to the anarchy. Like everyone can,
anyone can unlock it.
Okay. So now maybe we can test. Well, also something I want to mention is that in this case, like we are going to deploy the contract like every time, right? Because we are going to write like over and over. So maybe is there a way to save these 3 lines? And there is a way to do that. You can like inside the describe, you can do, I think you have before and before each. I think you have like these 2 functions. Before is just like before all the tests once, and before each it runs before every test, right? So we are going to copy this. Okay, let's copy this deploy functionality here. We probably want a variable here. Oh, okay, yes, we need this to be async. Okay, so is this clear? What is this doing? This
and
is
now
like
you have that lowercase greeter variable available. It runs before it does line 12, it runs through your before each, and then before it does line 16, it runs through your before each. Yes. And it sets up that greeter variable for you.
And if you do this, if you use before instead,
it won't run before 16. It will only run before 12.
Only once. That probably in some cases you might want to do that, but in this case, like let's deploy a new instance for every test. Okay, so soon return the new greeting once it changes. And let's add here, and it is unlocked, right? Okay. So now, okay, we can leave this as it is. But now here we need to run or to send this unlock transaction. So let's say greeter, and it is, don't remember, unlocked. And let's wait for this. And I think this will be the same, right? Like now the contract is unlocked, and then we can now call set greeting, and this will work, hopefully.
Hopefully. I'm like 60% sure on this one. There's a lot going on here.
You, Eda? Like 60?
I'm more optimistic. Like I'm.
Thank you, Eda.
So much more confidence.
Okay, let's see. Compiling, because we made some changes.
Hey, all right.
It's working.
That's fast too. So you could have a whole contract suite, right? You could have multiple contracts that all have to talk to each other. You orchestrate your whole system, bringing some up. Often you're going to be interfacing with contracts that exist on mainnet. So you bring up some mocks locally. Maybe you'll have a mock ERC20 that will represent some other ERC20 that's already deployed. You'll send that thing around. You'll run it through your whole system. You'll make sure all your tests work. And then what do? You deploy to a test network. You'll deploy to mainnet. We haven't talked about mainnet forks yet. Maybe one little interesting thing while we're talking about all these different GETH nodes and RPCs, you can actually use Hardhat to take the current state of mainnet and then just run it locally from then on. And so you could take something that already exists on mainnet and you could do a mainnet fork, and then you could deploy your stuff, but just locally, but to a fork of mainnet that's stored locally, which is really, really interesting and fun, and a fun way to test things. Just getting that out there, knowing that it's there eventually. You won't want to mess with it right away, but mainnet forking is also a really cool thing.
Yep.
So what have we covered? Have we covered everything? What would it take to, if we wanted to put this greeter, just if we wanted to YOLO it to Rinkeby or something like that? What are the last
steps? Let's go for it. Let's go.
Should we? Okay, maybe if we can get it done in 10 minutes, we might as well do it. If it goes longer than that, maybe we'll save it for next week.
So something that you might want to look at is the configuration file of Hardhat. So you have a bunch of things here that you can read the documentation if you want to go deeper, but we are going to take a look at this networks property. So whenever you run a script with this npx hardhat run, and then the script, and then we say like dash network whatever, is taking all the information from here. Like for localhost, I think it is here maybe. Yeah, look at this. Like this is like the default network object on the Hardhat, and we all don't have that, but by default it has this. And then also get designers by default. But imagine that we want to use Rinkeby. For example, let's try to deploy our contract to Rinkeby. So we will need to go to the Hardhat config file, and then add a networks, and then it's Rinkeby.
And there's even the private keys that come with it. This is going to be interesting here because we're going to almost need to create a deployer account that's separate from the other accounts.
Okay, we had some here, right? Providers from Rinkeby. Oh, mainnet? No. What utils?
I think we had like a
Yes.
private key in like our end file as well, right? We can use that.
Oh, yeah. That's true. Yeah, so let's copy this here. So the URL is going to be this one, but we don't have let's install real quick the .m package. Remember that we use this for like getting these to work.
And just tripling down on what we're doing here. We have a bunch of local accounts for Hardhat. And if we try to use one of those local accounts to deploy, those local accounts have the private keys exposed. So as we load them up with Rinkeby to be able to do the deployment, someone could technically get in and steal our Rinkeby. So you don't want to use those local accounts. You want to generate a new account and have it in your .env file and make sure your .env file is get ignored. And you want to have that private key come in there, and we'll fund it, and then we'll use it to deploy.
That makes sense, because this account, I mean, this is the provider. Remember that we have this util file on like yesterday, and we use like these URLs to connect into providers. So this is the way that you tell Hardhat when you use the Rinkeby network, what provider do you want to use. And for signers, you can use this account property, and you can set the private key directly here. And I think you can also have a mnemonic, right? So you can have like a mnemonic and then having like multiple accounts. And since we already have this, if you remember from yesterday, we have like these variables already set. So what I'm going to do is copy. Hopefully it doesn't get, okay, let's see what happens.
We're probably going to expose something here.
Yeah, I mean, it's fine.
I mean, if we just create a brand new one maybe and then fund it.
No, I mean, it doesn't,
Okay.
I mean, this already, I mean, doesn't have any value, I think. I mean,
okay.
Yeah, let's
you
paste
at
it
home
here.
be very very
Don't do
careful about copy pasting around private keys and having them in your local. Like, I would say that like 1 out of 4 developers I've worked with at some point has accidentally pushed a private key to GitHub and lost like thousands of dollars. So don't do this. Like, be very careful and very aware of what private keys you have where, and if they're dev accounts or real accounts, and make sure it's in the get ignore.
Okay, so let me test this real quick. Get balance. Let's say let's get signer. Let Rinkeby signer. So let me see if this works. So where this Hardhat signers? I think. Okay. Well, I think we can do that. Let's paste this. I'm just trying to see if it's working correctly. I'm going to. This will be. Well, let's call it signer. So if I call this script with Hardhat run,
is it going to be the 0 account, or is it going to load our new account that we have from our environment? We'll find out.
I think we need, if we, no, look at balance now. If we do this network, if we do this, it's going to use, let's check it. This will be like the Hardhat config, right? So this is like the 10,000 ETH. Yeah, like we send some. But if we do Rinkeby, that's why we configure this network here.
It's going to select the network, and then it should hopefully use our account from our environment.
Like the number.
Neat.
Yeah, I think I have it here, and it's the. So let's see. I think it's this one. Yeah, I think.
If you want to copy paste that to chat, I can send you some Rinkeby.
I probably have some.
Okay.
Yeah.
Oh yeah.
Like we have been like using like the faucet before. So let's see. If we do this, hopefully we will.
And did you bring that in through the environment variable, or it was already in this folder somewhere? I feel like I never saw you bring the private key in, but maybe you did it off screen.
No, I did it here by very carefully. Like I just like copy these two files here from the day 2 to the day 3, and then
without clicking them to show them.
Yes.
Okay, cool, got it.
So let's see. So this will be connecting to, yes, it's working.
Great work.
So we are connecting.
Okay.
So we are using like Hardhat for all like local development, but as you can see, we can also connect to Rinkeby or mainnet or whatever. So Hardhat is not only for local development. Okay, so now I think if we want to deploy that contract, it's just going to be npx Hardhat, run scripts, deploy, and then network, right?
And what's the deploy script have in it? Can we look at the deploy script real quick before we fire it off? It just loads up the greeter and deploys it with hello Hardhat. Should we say hello Rinkeby? Should we change our greeter to be, because it's going to be on Rinkeby. It's going to be on a public network now. Ooh, one other thing. When you go to a public network, I don't think you want the console log stuff there anymore. I don't think the console log stuff works in a public network. So you probably want to carve that out of your contracts as you start going public. Yep. Oh man, you just deleted it too. I just would comment it. It's gone. Carlos says no more.
No more consoles. So should we go for it? Let's
go for it. Yeah. I like that we just like wildly change our contract and then ship it to Rinkeby.
Yeah. It's compiling because we made like this change.
And just to dive into that, there's just like a lot of more overhead that comes with that console log. There's all these different overrides. It worked. We deployed a contract. We should be able to go to a disinterested third-party Etherscan. We go to Rinkeby Etherscan and paste in that address. Is it a contract? It hasn't found it yet. Give it a second. Okay. Our node's faster than their node. they have a lot of indexing.
Yeah, it's working now. Contract, yeah.
And can we look at the contract code? We should be able to see the bytecode of the contract, and we should see that it's not verified yet, right? This is what everybody sees. This is our contract right there.
Yeah, like actually it's start with 6080, right? And then if we go to the artifacts, it should be the same, right? It should be the same.
I think all contracts start with that.
Okay, then.
Yep. But down the line, it's more stuff. Yeah.
Yeah. It ends on 33. I don't know.
Yep.
So yeah, I mean, the next step will be to verify the contract, but maybe it's too late for that. But
well, can we run a script against it? Can we go set? We can run our tests, I think, right? Because our test bank will run against. Ooh, but our test is set up to say hello Rinkeby, not hello or hello Hardhat.
No, but that's perfect because then that will break, right? So if we do this test, no, let's do npx Hardhat test, then network.
It should fail on this, right?
It should fail, yes.
And is it going to deploy? I don't even know what it's going to do here. It's going to deploy as the Hardhat account?
Yeah, that's true.
I think it is, right? Which like somehow works because they keep it loaded up on Hardhat. Like, I don't know, like that account shouldn't really, it's bad practice to be using an exposed private key to deploy a contract on a public network.
Yeah,
but most of the time people just run the command like you just did and they don't even realize what's going on under there, right?
Yeah, like probably like if you want to run test against like Rinkeby or mainnet, you will probably want to do this. Like you use like the get contract at, and then you will paste the address, right?
There's sort of like this idea of I'm deploying locally, and we're even like bringing up our own chain and deploying everything there and then shutting off the chain. It's very ephemeral. But as soon as you put a contract out on a public network, that artifact becomes very important and very solid. And you're more often going to write a test bank that goes against that specific contract, not, orchestrate the whole thing and test it.
And just maybe we won't do it today, but just wanted to point to this Hardhat Etherscan plugin, which is what you can use to verify your contract. So you just like install this plugin and add it to your Hardhat config, And then I think you just have to get an Etherscan API and put it here. And then I think it's like a command, like a verify command, the network, and that will verify your contract.
And you can do it manually too. You can just go to Etherscan and you go to the contract and say verify, and you just paste in the source code and tell it what the compiler version is, and it should get the exact bytecode compiled. All right, I think we did it. And right? Yeah, go ahead, Edda.
Just to add note on the verify. So like when you verify the contract, like it will show the contract code on that Etherscan interface. So like you will have like a green tick, and like you can see the actual like Solidity code. So just like as we were seeing before in the DAI contract.
And so security through obscurity does not work on a public blockchain. So just because we have this cool greeter and it's packed into bytecode and no one can really tell what's going on there, people can decompile that bytecode. There are lots of ways that people can hammer and steal from your contract. So don't think that like you'll obfuscate it by not verifying it. You almost want to verify any contract that anybody's ever going to use, just so that source code is out there and everyone knows about it. And everyone can even use Etherscan to interface with your contract if everything else is down.
Yeah, and the same thing with this private properties.
Yeah, it's not really like, private. That's a great point. Yes.
Yeah. Yes. Like maybe you can think, oh, so no one can access to this variable because it's private, but that is not the case. Like there is like I think you can even do that with ethers. It has like a get storage at 0 or something like that, and it will get like the value of the first variable. So yeah. So this is just if you want to hide it from other contracts, I think, or but you can
inheriting
actually,
from it. Yeah. If someone were to inherit the greeter, the parent wouldn't be, or the child wouldn't be able to use that variable, basically. Awesome. So much cool stuff. We started tinkering with Solidity here. We showed you how to spin up a GETH node and talk to the network. Then we brought up Hardhat and showed how all that local orchestration works and how we have some really cool tools these days that let us build and test and orchestrate smart contracts. Great work, Carlos. Thank you for being here. We're all sick. Thank you, Edda. Thank you, Carlos, for being here. I need a drink too. Any closing thoughts here? Hardhat Day was a success.
Yes.
Yeah, just a reminder. So I do still have the GETH node up and running. So we did find another peer. So like,
you have more peers?
Nice.
Now Hooray. 2 peers.
Two peers. Goodness.
Let's just look at that one moment. Yeah, I think.
And you're just getting blocks one at a time now. That's what a good node looks like, when you're just getting one node at a time, or one block at a time. See. Yep.
I think that
there was a peer connecting. Yep.
Yeah, so like you can see all the blocks I'm getting, and yeah, just closing. It's running.
Cool.
That's awesome. Great. All right, Hardhat Day was a success. Thank you for coming. Okay. Thank you, Edda and Carlos, for working through it, even though we're all sick. Hearts. See you guys.
Thank you.
Bye, everyone.
Bye.